Now that we've learned how to add matrices and some properties about them, we're going to take the next step forward and learn to multiply matrices. Before we do that, there's a few things we need to straighten out. The first one is we need to discover or be told when we are allowed to multiply matrices together, because you are not always allowed to multiply any two matrices together. So we need to go back to the idea of the dimensions of a matrix. And if you remember, we talked in the last video that when we write matrix down and we're describing their dimensions, we say it's the rows by the columns. Alright, so when you are multiplying a matrix A times a matrix B and you write down the rows by columns for each matrix, so this would be row by column and row by column, your column of the first matrix must equal the rows in the second matrix. If these two inside numbers are not equal, you will find out very quickly that it is impossible to multiply your matrix. Alright? Your answer, on the other hand, will have these dimensions: the row of the first matrix and the column of the second matrix. These, again, are the dimensions of your answer matrix. So I'm just going to say it one more time, because repeating makes it stick. The inside numbers have to be equal in order for you even to multiply the matrix, and then your answer matrix will have these dimensions after you do the multiplication. So let's look at example 1. Example 1 says state whether the product A times B is defined, meaning can you do it or not. And if it is defined, then you give the dimensions of the product matrix A times B. So we're going to look at these, and I'll try to use the same colors. And I have matrix A and matrix B. This is a 4 by 3, so try to picture that. And this matrix is a 3 by 2. Your first job is to look at the inside numbers. That is, the column of the first matrix must equal the rows of the second matrix. And the answers are both 3. So far, yes, this is a defined product that we can do. And then the dimensions of your matrix, once you multiply it out, will be a 4 by 2. So we first say that yes, it is defined, meaning we can do it, and that your answer matrix or your product matrix will be a 4 by 2. All right, let's move on to the next one. So here I have a 3 by 4 matrix being multiplied by a 3 by 2 matrix. And you look to the inside numbers, the columns of the first matrix. Does that equal the rows of the second matrix? And the answer should be no. So there's no reason to even move on and try to state the dimensions of an answer matrix, because you won't have one. This one is not defined, meaning you cannot do the multiplication on these two matrices. So here's guided practice time. You guys look at 1 and 2 and decide if they're defined, and if they are, give the dimensions. All right, looking at guided practice number 1, you start off with the inside numbers and see that they are both 2. So this one is indeed defined. And then you look at the outer numbers, and you would see that your answer would be a 5 by 2 matrix after you multiply it. This next problem 2, looking at the inner numbers, 2 and 3, do not match up. So immediately you should know that you cannot multiply these together, and they are not defined. Well, now we're ready to take on the task of multiplying matrices. This can be very disconcerting when you first start. The key is you need to stick with it, and eventually your brain will wrap its head around it, your head around it, and you will be able to do these, and you'll wonder why it was so hard in the beginning. But it's hard for everyone in the beginning, so don't feel bad. We're going to look at the key concept first, and I need you to pay attention to the color coding, because that is where everything is. You have matrix A, B, C, D, and these are all elements in your matrix. Please notice this is a 2 by 2 matrix. Matrix B, you have E, F, G, H. It is also a 2 by 2 matrix. So you know off the bat that your inner numbers are the same, so in fact you can multiply it. And your outer numbers tell you the dimensions of your answer matrix, so your answer matrix will also be a 2 by 2. Now let's get to the multiplication part. Your first job is to look at the first row in red here and the first column in blue. Your job is to take your first row, first column, letter A, and multiply that times first row, first column of B. All right, and they write it right here, A times E. Then you will add to it the first row, second column, to the first column, second row. And this is where it starts to get confusing. So if you just watch my pen, you do A times E plus B times G, and you will get your first row, first column element of your answer matrix. I'll do it again with this element here, which is your first row, second column. You take A times F plus B times H, and there it is written out. Moving down to how we find the second row elements, you take your second row numbers and you just kind of ignore this one right here now, and you're going to take A times E plus D times G, and then that will give you your element in that second row, first column. And then you will take your second row numbers again, but now you're going over to the second column here, and you do C times F plus D times H. So really confusing, I understand. Let's do a couple examples, and hopefully you'll get a little more used to it. So I'm going to, I guess, rewrite these numbers down because I am multiplying these matrices, and you should always start off by writing your matrices as if you're multiplying them. So I have the numbers 1, 3, 4, and negative 2, and I'm multiplying that times 5, 9, negative 7, and 6 matrix. First job always is to check your dimensions. I have a 2 by 2 here, a 2 by 2 there, and so I can indeed multiply them, and my answer will be a 2 by 2. And I'm going to write a middle step matrix, and then we'll clean it up and do a final step matrix. So here we go. My first job is to look at the numbers in my first row, and I'm going to multiply those by the numbers in my first column eventually. So my first job is to do, and I guess I have to write in black, 1 times 5. I'm getting that from here, 1 times 5, and I'm going to add to it 4 times 9. And leave that there until the end, and then we'll fix it up. That is your first element number, though. Then you need to move things over. Oh, and it won't let me erase that. So I'll leave the 5 and the 9, and I'll change my color, I guess, to green, so you know what I'm looking at now. I am looking at the negative 7 and the 6, and I'm going to take my 1 times negative 7. So let's write that down. 1 times negative 7 plus the product of 4 times 6. And that will be my answer once I do it. Moving down to the second row. How you doing? Hang in there. Now I'm looking at the second row numbers. This 3 and a negative 2. And I'm going to find out my number for my second row, first column, by multiplying the second row with the first column, and then adding some products together. So I would take 3 times 5, and write that down, plus negative 2 times 9. All right, and then we'll get a number there. And then finally, I'm trying to get my second row, second column. In order to get that element, I will take my second row times the second column, and then add those products. So you start off with 3 times the negative 7 plus negative 2 times 6. And I fell outside there. Now that is the major setup, and you're pretty much there. Now you just need to clean up that matrix, and there's no reason a calculator couldn't be used here. So when you take 1 times 5, you get 5, and 9 times 4 is 36, and so your answer would be 36 plus 5 is 41. Over here you would take negative 7 times 1, which is a negative 7, plus 24, and you end up with 17. And for the bottom two numbers, 15 minus 18 is a negative 3, and negative 21 plus 12 or sorry, that's a times sign, minus 12, negative 21 plus a negative 12 gives you a negative 33. And that is your answer for that matrix multiplication. We'll do more together. But before we do, you probably want to know what these little pull tabs are. Well, if I was on my smartboard and I pulled that out, what this would say to you is a very important property of multiplying matrices. And that is that matrices are not commutative. Matrix multiplication is not commutative. And what does that mean again? It means the order does matter when we're multiplying matrices. So let me say, order matters. You cannot just switch these two matrices around. What do I mean by that? If I am telling you that I need the product of A times B, matrix A better come first and matrix B needs to come second. You cannot reverse the order and put B first and A second. You will get a total different answer. So that's what it means that multiplying matrix is not a commutative thing that you can do. So make sure your eye is putting the first matrix that comes in as listed first when you're doing your multiplication. All right, well, here's another guided practice problem, and this is one where I will actually run through the entire thing with you. But if you feel like you've got it or want to try it, go ahead and pause the video, but I'm just going to keep talking right through it and do another example of multiplying two matrices together. So we are multiplying matrix A times matrix B, and again, the order matters, so I will rewrite these down so I can color coordinate if I want to. B goes here. All right, and remember to check your dimensions always. Just quick, you don't always have to write it down, you can do it in your head, but it's a 2 by 2 times a 2 by 2, and my inner numbers match. Okay, these match, so I know I can do it, and then my outer numbers tell me I will get a 2 by 2 answer matrix. And I'm going to leave it a little wider this time because I'm going to actually put the numbers in. But when you get really good at this, you can leave out this middle part. So my first job is to find my first element in the first row and first column. So I will take the product of negative 3 times 1 plus 3 times a negative 3. I'll do it again. Negative 3 times 1 plus 3 times a negative 3. And write that down. So negative 3 times 1 plus 3 times a negative 3. All right. And then, and I didn't make my matrix nearly big enough, so I'm going to go over the edge, I bet. To look for my number in my second column, but my first row, second column, I'm going to take my first row and second column and find some products and multiply. So negative 3 times 5 plus 3 times the negative 2. One more time, that's negative 3 times 5 plus 3 times a negative 2. And write that down. So negative 3 times 5 plus 3 times a negative 2. Sorry about that. I can't erase it. All right. So now I need my second row elements. I will take second row times first column. So I will take 1 times 1 minus negative 2 times a negative 3. So let's write that down. 1 times 1 minus negative 2 times a negative 3. Moving over to my second row, second column, I will take 1 times 5 plus negative 2 times negative 2. That's 1 times 5 plus negative 2 times negative 2. And now you would multiply it through. So you get a negative 3 plus a negative 9, and again, that's what calculators are for. It's negative 12 for my first row, first column, and that's coming from here. Then I will take negative 15 plus a negative 6. That's a negative 21. Okay, it's starting to fill up. Then you do 1 times 1 plus, I don't know why that looks funny, that's a plus sign. 1 times 1 plus negative 2 times a negative 3, which is a positive 6. So 1 plus 6 is 7. And then finally, 1 times 5 plus negative 2 times negative 2, which is a positive 4. 4 plus 5 is 9. And that is your answer matrix. So let's move on to some matrices that aren't always a 2 by 2 in dimension. And we will see our properties again that we talked about in a previous video that we can distribute. And see if you notice, these problems are completely the same. I will do both of them, but they're the same in the sense that this is distribution property. First I will be taking matrix A plus C, which is no big deal to add, and then I will multiply it by A. And here I will take A times B matrix plus A times C matrix. So this actually might be a good guided practice for you too, if you wanted to pause the video and let me work ahead of you and come back and see if you're right. So I will start off doing what I'm told, and that is order of operations to add B plus C first. So when I add B plus C, I would get, and I'm going to do it over in the middle because I'm probably put A right before it eventually, so I don't have to rewrite it. But remember, order matters. So B plus C tells me I take negative 3 plus 1, which gives me a negative 2. Then I take 0 plus 4, which is a 4. I take 1 minus 3, which is a negative 2. And negative 2 plus a negative 1 is a negative 3. So there is my B plus C matrix. And now I'm told to multiply that by A, which I will rewrite in front of it. Now this one is a 3 by 2, 3 rows, 2 columns. So let's write that down and check our dimensions. This is a 3 by 2, and this is a 2 by 2. Again, you're checking those innermost numbers, and that tells me I can multiply them. And this tells me that my answer will be a 3 by 2. So I will go ahead and get ready for my 3 by 2. And I'm going to give myself more space, realizing that I write big. So your first job to find the first row, first column, is to find the first row, first column numbers. So I will take 4 times the negative 2, and I'm just going to do it right away. I know it's a negative 8. And I'm going to add to it 3 times the negative 2, which is a negative 6. All right? And then to find my second column number, I will take 4 times 4, which is 16, and then I will do 3 times a negative 3, which is a negative 9, so it's plus a negative 9. Next I move down, and I'm going to find my second row numbers by using my second row here to get them. So second row first column number will come from my second row first column. And I will take negative 1 times a negative 2, which is a positive 2, plus negative 2 times a negative 2, which is a positive 4. So plus a positive 4. Moving over then, I will take negative 1 times 4, which is a negative 4, plus negative 2 times the negative 3, which is a positive 6. And finally, and this is exciting because we've never done one of these before, I will take my third row to get my third row here. And I will take my third row first column to get my third row first column element. So I will take 2 times the negative 2, which is a negative 4, plus 0 times the negative 2. Well, that's just 0. Then finally, I will take 2 times 4, which is 8, plus 0 times the negative 3, which again is plus 0. So now we can clean this up quite easily and see that this answer is negative 14, and then 16 minus 9 is 7, 2 plus 4 is 6, negative 4 plus 6 is 2. I get a negative 4 here and an 8 there, and indeed you can see this is 3 rows by 2 columns, which is what these dimensions told us it would be. So that's multiplying that one. And now when I multiply B, or do B, I should see that I get the exact same answer. So I guess I will try to squish this up here in blue. So it's asking us to take matrix A times matrix B first. And so I will write this down as best I can in this small little space. and I will write matrix A, which is coming 4, negative 1, 2, 3, negative 2, 0, and I'm going to multiply that times matrix B, which is negative 3, 1, 0, and negative 2. And I have here a 3 by 2 matrix and a 2 by 2 matrix, so my answer will be a 3 by 2 matrix as well. And so I am just going to go ahead and jump and skip that middle step, and I am going to write this right away. And so what you do, the order is this. You take 4 times the negative 3, which is a negative 12, plus 3. Negative 12 plus 3 is a negative 9. Remember, you can rewind. Next, to find this element, I will take these, my first row, second column. 4 times 0 is 0, plus 3 times a negative 2, which is a negative 6. Moving on. Negative 1 times a negative 3 is a positive 3, plus a negative 2. 3 plus a negative 2 is 1. Next, negative 1 times 0 is 0, and 2 times a negative 2, negative 2 times a negative 2 is a positive 4. 2 times a negative 3 is a negative 6, plus 0 is a negative 6. And finally, for my third row, second column, I use the third row, second column. 2 times 0 is 0, and 0 times a negative 2 is 0. And remember, 0 is a number, and that is my answer for A times B. Now, I need to fit in here and do, oh good, I have more room, B times C. Or sorry, A times C. I'm going back and read the directions. I'm supposed to do A times C. I will do that in red. And I will do A, which is 4, negative 1, 2, 3, negative 2, 0. Remember, you can skip ahead of me. And C is, whoops, not that big, a 2 by 2. These all work, by the way. 1, negative 3, and 4, and a negative 1. And we can check this. Again, this is a 3 by 2. This is a 2 by 2. And so my answer will be, I'm just going to move this over for now, a 3 by 2 matrix. And I'm going to just talk it out. So to find the first element in my first row, first column, I will take my first row, first column. 4 times 1 is 4, plus 3 times a negative 3 is a negative 9. So I have 4 plus a negative 9, which is a negative 5. All right, moving on. I have 4 times 4, which is 16, plus 3 times a negative 1, which is a negative 3, and that answer is 13. Negative 1 times 1 is a negative 1, and negative 2 times a negative 3 is a positive 6. So I have 6 plus a negative 1, that is 5. You don't want to make mistakes on these. Negative 1 times 4 is a negative 4, plus this will be a positive 2. So I have a negative 4 plus 2, that is a negative 2. 2 times 1 is 2, plus 0 is just 2. And 2 times 4 is 8, plus 0, and that's just 8. Now, the question was, though, add these together and make sure you get the same thing. So I will take blue matrix, which I should probably rewrite down, which was negative 9, 1, negative 6, negative 6, 4, 0, and I'm adding together, or adding to it, negative 5, 5, 2, 13, negative 2, and 8. Notice they're same dimensions, and I'm going to add these together. And I will get negative 9 plus a negative 5 is negative 14. Negative 6 plus 13 is 7. 1 and 5 is 6. 4 and a negative 2 is 2. Negative 6 plus 2 is negative 4. And 8 and 0 is 8. And remember, what you were supposed to notice is that these two were the same, proving that you can use distributive property for matrices. So since we proved there's distributive property for matrices and its multiplication, we will show you the concept summary for the rest of the matrix properties. And that is, there is an associative property, meaning you can multiply in different orders. That's okay. There is a distributive property with your number on the left side that works. Distributive property with a matrix on the right side works. And again, you can take a scalar and multiply it by a matrix and do it by, or take the scalar and multiply each matrix separately and you will get the same answer. But please notice and write this down, there is no commutative property. No, no, no. And that will become very important as we move on. So here is your guided practice. If you needed more practice, to do number 4, 5, and 6 and see what answers you get. The answers to 4 and 5 should be the same, so that'll tell you if you get them right. And your answer to number 6, you would multiply the matrices first and then multiply by negative 1/2. And so that matrix will look like this. And it's a 3 by 2. And so here this is a 3, a negative 5, and a negative 7/2 if you're doing those. This last problem is really the meat of matrices and why we use them. You can use them, like we said, for any large values of numbers, but this is a business application for matrices, and it's called a cost matrices, and we'll do these eventually as time goes on too, and later down in the chapter. But it says matrix multiplication is useful in business applications because an inventory matrix, when multiplied by a cost matrix, results in a total cost matrix. So it tells businesses how much product they have on hand, money-wise, and how much it's costing them to store that inventory. So for the total cost matrix to be meaningful, the column labels for inventory matrix must match the row labels for the cost matrix. So your column must match the row. That's just what they're saying there again. So we'll use this example below, and it takes a little space. It says, 2 hockey teams submit equipment lists for the season shown. So you have your women's team and you have your men's team, and they need 14 sticks, 30 pucks, and 18 uniforms. Men need 16 sticks, 25 pucks, and 20 uniforms. They tell you how much each stick costs, and each puck, and each uniform, and so we'll use matrix multiplication to find the total cost of equipment for each team. So we're going to start out writing this chart in a matrix form, and this is our inventory matrix here. And so we're going to look at the women's team compared to the men's team. And we are going to look at 3 elements. We are going to look at sticks, we are going to look at pucks, and we are going to look at uniforms. And now we're going to fill in those numbers based upon the chart. So women had 14 sticks, 30 pucks, and 18 uniforms. And the men had 16 sticks, 25 pucks, and 20 uniforms. We're going to take that matrix and, well, now we're going to write our cost matrix before we do anything with that. So let's write our cost matrix over here. And it will be written in a 3 by 1 form. Okay, so my sticks cost $60, and my pucks cost $2, and my uniforms cost $35. So let's look at the dimensions of these two pretty quickly. I have a 2 by 3 matrix here. I have a 3 by 1 matrix here. So because of these, I can multiply them, and my answer will be a 2 by 1 matrix. So let's take these matrices and write them right next to each other and get them ready for multiplication. And I am multiplying that by the cost matrix, which I guess I'll do in green, is 62 and 35. So now let's multiply these things together. I'm going to take my first row times this only first column and multiply it, and I will write it out the long way, and I end up getting 14 times 60 plus 30 times 2 plus 18 times 20. That's my first row, first element number. Oh, I didn't mean 20, I meant 35. Let me fix that. Probably saw that right away. That is a 35. Okay. That was my first row element, and remember it is a 2 by 1 matrix, so 2 rows, 1 column, so this is going to be one big column right here. Then finally I'm going to take second row only column and multiply it. 16 times 60 plus 25 times 2 plus 20 times 35. And then when you clean that up, you will see that you get 1,530 and 1,710. And what are those? That is the cost of the equipment list for women and for men. And so you can imagine if companies have a large inventory or a ton of different men's and women's and types of items, that writing equations and figuring them all out separately would be extremely tedious. And you can see perhaps how computer programs are written to do this for the companies, which makes it even better.